In this video I'm going to go through some tips on naming organic compounds. So the way that chemists name organic compounds is using the IUPAC system. So this was developed in 1892. It gives a set of rules on how to name compounds, but the rules were last updated in 1993, and even though that's over 20 years ago, some textbooks still use some of the old rules, and so it's taken a while for some of these rules to come through. So there might be two ways to name some molecules, and I'll show some examples of that as we go through. So here are my tips on how to name organic compounds. The first thing I would do would be to find the highest priority functional group, and I'll go through a table, a couple of slides that gives the list of the priority of these functional groups. So find the highest priority functional group, and then find the longest carbon chain that contains that highest priority functional group. So that will then be the parent. We're then going to use the suffix of that highest priority functional group. So if it's a carboxylic acid, it will have a suffix as an oic acid. If it's a alkene, then the suffix will be that -ene at the end. We want to number the carbons so that we get the lowest numbers for the highest priority functional group, and then the lowest numbers for any side chains that are coming off that as well. We want to name any other side chains or other functional groups using the prefixes, and then where there are several side groups or other functional groups, they are then listed in alphabetical order. And then in terms of grammar, we put a hyphen in between numbers and letters, or numbers or letters and names. If there are two location numbers or letters, then those are separated by commas, and we'll give some examples of those. So here is the first page of the table of the list giving the priority of organic functional groups. So this is not a comprehensive list, this is targeted towards the functional groups that we're going to be studying in this course. So carboxylic acids are the highest priority functional group, so it gives their structure. Where it is it's not named as a carboxylic acid, if it's a side chain, then the prefix is given. The suffix there, oic acid, so where the carboxylic acid is the highest priority functional group, contains that, then it will be a something oic acid, methanoic acid, ethanoic acid, for example. So we've got the example there, ethanoic acid. These prefixes that are shown in grey, we won't be using those throughout this course. So then we have an ester. So we have a structure of an ester, so C double bond O, O, R, and its suffix is O8. So methyl is describing the R group, and then ethanoate. So eth meaning the two carbons there that come from the carboxylic acid, a portion of that, and then the suffix O8. This list of functional groups is close to the order in which we'll study them this semester. So I'll go to the second page of this list. So we're starting with alkyl halides and ethers and alkanes, and then we're basically working our way up this list. So that would be the second page of the list, and I'll go back to the first page. Then we're working our way through to carboxylic acids. So amides, the suffix is an amide, so ethanamide. Aldehydes, so the suffix is al, so ethanal. And ketones, the suffix is an -one. And here's an example of where there are two different ways of naming it. So the new way of naming it is to put the location there before the -one, so pentan 2-one, but the older way would be to name it as a 2-pentanone. So both of these ways would be acceptable for this course. Alcohol, so it contains an OH group. So where it is a side chain, so it might contain both an aldehyde functional group and an alcohol, it will then get named as an aldehyde since it's the higher priority, and so then the alcohol then becomes the side chain, so it would be a hydroxy something al. For alcohols, the suffix is ol, So an example of that is ethanol. We go to the second page of the table, so thiols. So we have an SH, we won't be using that as a side group, but the suffix there being thiol, so methane thiol is an example of a one carbon compound containing an SH group, so a thiol. Amines, so this is a nitrogen contained with hydrogens or R groups attached to the nitrogen. So where it's a side chain coming off the hydrocarbon, then it is an amino group, and the suffix of the parent is an amine. So if it is a one carbon containing the NH2, that would be methanamine. We then go through, so alkenes, so the suffix is -ene, propene, butene, etc. Alkynes is a Y there instead of the E for alkenes, so alkynes have a triple bond, so butene, so one butene, or but one ine, but two ine, to indicate the location of the triple bond. For alkanes, so carbon-carbon single bonds, so if it's a side chain, then it might be an ethyl, methyl example. The suffix for alkanes is -ane, so pentane is a hydrocarbon with 5 carbons and single bonds. And then ethers are alkoxy groups, so methoxy, ethoxy, etc. And then they're named then, so ethoxy propane would be an ether, so has 3 carbons in the longest part of the chain, and then ethoxy would be a CH3CH2O propane group. And an alkyl halide, so is a bond to either fluorine, chlorine, bromine, iodine. So these are given the prefix halo something, so chloro or bromo. So chloromethane would be 1 carbon with a single chlorine attached to it. So I'll work through some examples now. So starting off with alkanes, so we have this structure here, and so highest priority functional group is an alkane. I would then look for the longest carbon chain, so it's not necessarily the one drawn out from left to right there. We're looking for the longest carbon chain. So in this case here, it contains 1, 2, 3, 4, 5, 6, 7 carbons. So this would be a heptane. So then we want to number the side chain. So there are methyl groups there coming off carbons 2 and carbon 5. We want to number it that way rather than numbering the reverse. If we were to number the reverse, it would be carbons 3 and 6. So we want the numbers to be lower. So the 2, if we're numbering from right to left, the 2 is going to be lower than if we numbered from left to right with a 3. So now we've got a 2-methyl, a 5-methyl, and a heptane. So we want to put those names together. So this will be 2,5-dimethyl heptane, and then the words will just run together. So this is indicating we've got a methyl group coming off carbon 2, methyl group coming off carbon 5, and the longest carbon chain is a heptane, which is 7 carbons. This is a haloalkane, and so the halogens are the lowest priority, so this is going to get named as this cycloalkane. So there are 6 carbons in that ring, so it's going to be named as cyclohexane, and then we've got a chloro and a bromo coming off the cyclohexane. So these are equal in terms of their priority, so they will just get arranged alphabetically. So be 1 bromo, 2 chloro. So B for bromo coming before C for chloro, and so then the bromo comes first, and we're going to number it from 1, 2 that way. So any other way of numbering it would not give us the lowest numbers. So 1 bromo, you can see there hyphen in between that number and the letter, between the letter and the number, so hyphens in between those. So 1 bromo, 2 chlorocyclohexane. This one here is an alkene, So alkenes are a higher priority than alkanes. So we're looking for the longest chain that contains that alkene. So this here would be 1, 2, 3, 4, 5. So that is pent, 5 carbons. So even though we've got a longer carbon chain here, 1, 2, 3, 4, 5, 6 would be 6 carbons in that chain, but that does not contain the alkene. So we want to have the longest chain that contains the alkene. So it would be 5 carbons, and we're going to number it so that the alkene contains the lowest number. So this would be a pent 1-ene according to the new nomenclature. So you could also call this a 1-pentene. Then we want to indicate these other 2 carbons here. So this would be an ethyl group coming off carbon number 2. So then we can put all this information together. This will be 2-ethyl pent 1-ene. Another example of an alkene is shown here. So this one has 1, 2, 3, 4, 5, 6, 7 carbons in the longest chain. So this will be a hept 3-ene. We also want to indicate any geometry about this one. So with this double bond, this could be either in the cis or trans configuration, and so that is then indicated. So here the 2 hydrogens are on the same side of the double bond, the 2 alkyl chains are on the same side of the double bond, so that it has a cis geometry. It's also known as a Z geometry. So we'll put this together. This will be cis hept 3-ene, will be the way that we'll be naming that in this course, but it can also be known as Z hept 3-ene. The next example then is for an aldehyde. So this contains both an aldehyde functional group and an alcohol functional group. So according to our table, aldehydes are a higher priority than alcohols. So this molecule is going to get named as an aldehyde. So there are 3 carbons in this molecule. So carbon 1, 2, 3. So it would be propan-al. So prop telling us that there are 3 carbons, and the suffix here of al is indicating the aldehyde. So the aldehyde here having double bond O and then the hydrogen. We don't have to number where the aldehyde is because an aldehyde must be at the end of the chain. So this is automatically carbon number 1. We've then got this alcohol group coming off carbon number 2. So its prefix is hydroxy. So this will be a 2-hydroxy propanal. So that shows that there's the hydroxy group coming off carbon number 2. There are 3 carbons in that chain, and it has an aldehyde there which will be at carbon number 1. So 2-hydroxy propanal. The next example then is for an amine. And so in this one here we have 3 carbons in total, and the highest priority functional group is the amine. So this one, the suffix becomes amine. So this is a propan 2-amine. So prop telling us there are 3 carbons, and 2 telling us the location of the amine functional group. So it's coming off carbon number 2. So the new rules would put the 2 there just before the amine, so propan 2-amine. But with the old rules, it would be named as a 2-propan-amine. So either way will be acceptable for this course. This next functional group is an amide. And so in this we don't have one continuous carbon chain here. We've got the amide that contains the carbonyl, so there will be 2 carbons in that chain, and then we have some more carbons that are attached to the nitrogen. So the amide, which is the C double bond O into the nitrogen, so that contains 2 carbons there, so it's ethanamide. So that takes care of those atoms there, those carbons, the oxygen and the nitrogen. So we still need to name these carbons over here. So we've got an ethyl group attached to the nitrogen, so it's an N-ethyl. We've got a methyl group, so 1 carbon attached to the nitrogen, so it's an N-methyl. So we want to put all of those names together. So we've got an ethyl coming before the methyl, so this is alphabetically, so E coming before the N. So we've got the ethyl group coming off the nitrogen, and we've got a methyl group coming off the nitrogen, and then ethanamide is the amide functional group. So we've seen before that the carbon chain might be numbered to indicate where an ethyl or methyl group might be coming off. In this case here, these side chains are coming off the nitrogen rather than coming off a numbered carbon. The next functional group is carboxylic acids, and so that's the highest of all of the highest priority of all the functional groups. So we want to name the longest chain that contains the carboxylic acid. So this would be 1, 2, 3, 4, 5, 6, 7. So 7 carbons. It's a carboxylic acid, so it would be a heptanoic acid. And then there are 1, 2, 3 groups. So 3 carbons coming off carbon number 2 of the heptanoic acid. So it's a 2-propyl heptanoic acid. So again, the longest chain must contain the highest priority functional group. So this would not get named as a 9-carbon compound. It would be a 2-propyl coming off the heptanoic acid. So a propyl group coming off carbon number 2 of heptanoic acid. Again, we don't have to number where the carboxylic acid is. So similar to an aldehyde, it must be at the end of the chain, so we don't have to say that it's a 1-oic acid. So heptanoic acid will indicate where the carboxylic acid functional group is. With benzene compounds, so in this one here, again, we have to think about what is the highest priority functional group. So the benzene ring is going to be a higher priority functional group than the 3-carbon unit there, and so this will get named as a something benzene. In this one, we've got a propyl group attached to the benzene, so this will be propyl benzene. We don't have to indicate where the propyl group is attached to the benzene. So there's only one group attached to the benzene in this instance, so it's just propyl benzene. A similar example, except this time we now have this alcohol group attached to that propyl chain. So thinking back to our steps, we need to think about what's the highest priority functional group. So now this alcohol is a higher priority than the aromatic ring, the benzene ring. So this is going to get named as an alcohol. So there are 1, 2, 3 carbons of that chain, so it's a propanol, and the alcohol group is at carbon number 2, so this will be propan-2-ol. And now we have this benzene ring being named as a side group. So when the benzene ring is named as a side group, it's called a phenol. So not to get confused with phenol, but phenol. So phenol is the benzene with an OH group attached to it. Phenol is when the benzene ring is the side chain. So carbon number 1 has the phenyl group attached to it. Carbon number 2 is where the alcohol is coming off. So we put those together. This will give us 1-phenyl propan-2-ol according to the new rules, or according to the old rules, we could just move that 2 out to in before the propanol, so 1-phenyl 2-propanol. And the last example is for a disubstituted benzene. And again, there are 2 ways that we can name this. In this example here, we've got the benzene ring, we've got a carboxylic acid, and we've got an amine. So the carboxylic acid is the highest priority functional group. So where the carboxylic acid is directly attached to the benzene ring, then that molecule is called benzoic acid. So from the benzoic acid, we've got this then amino group attached, and it can either be named as being attached at the 4 position, so this would be carbon number 1, 2, 3, 4 of the benzene, so the amino group is attached to carbon number 4, or for disubstituted benzenes we can use the para, meta, ortho prefixes. So 4-amino or para-amino, the P short for para. So this would be 4-amino benzoic acid, or another way of naming it would be para or p-amino benzoic acid.